The Taj Mahal took 22 years to build, 20,000 workers, no project management software, no coordination meetings, no emails, no drawing register, no RFIs, no clash detection reports. Every decision made in person, on the ground, by people who had never seen a Gantt chart in their lives. And somehow it came together perfectly, beautifully, in a way that most modern buildings simply don't. Not a single AutoCAD file, no Revit models, no drawing set. If they could build Taj Mahal without construction drawings, why do we need them today? That's what this video is about, and I promise you the answer is more interesting than you think. Before I answer that, I want to stay with the history for a moment because I think it's genuinely worth thinking about. It's not just the Taj Mahal, the pyramids of Giza built around 2500 BC, still standing, geometrically precise to a degree that is frankly embarrassing compared to what we build today. Ajanta and Ellora caves, not built but carved. Monolithic rock carving on a scale that is almost impossible to imagine. No assembly, no joints, no separate pieces, just subtraction, chisel to rock, generation after generation, until a temple emerged from inside the mountain. One building, multiple human lifetimes. Now I genuinely don't know how exactly they communicated the design intent for these kind of structures. We have fragments, some sketches from the ancient Egypt, some rudimentary plans, but nothing resembling or nothing come close to what we would call a construction drawing set today. The most likable answer is that the knowledge lived in people, in master craftsmen who trained the successors, who trained more successors. The craft was the communication. You didn't draw it, you showed it. You demonstrated it. And because these projects ran for decades and centuries, there was time for that knowledge to transfer slowly, person to person. And here's what strikes me the most. Those projects had the one thing modern construction absolutely does not have: time. Today, construction is done for profit. That's not cynical, it's just the reality of how the industry works. Developers are borrowing money. There's interest on that capital every single day. There are investors expecting returns. There are tenants waiting to move in. There are handover deadlines written into contract with penalties attached. Nobody is waiting 22 years. Nobody is waiting 22 months if they can help it. And think about it this way, maybe those long timelines weren't just because the work was complex. Maybe part of the reason these projects took decades and even centuries is because there was no drawing. Error was part of the process. Something didn't fit, you reworked it. A proportion felt wrong, you adjusted. That kind of iterative, on-the-spot decision-making was acceptable because time was not a constraint. Nobody was paying interest on a construction loan. Nobody had a lease commencement date. The emperor wasn't answering to the investors. So the rework happened quietly, absorbed into the decades, and we never heard about it. What survived is the finished thing, and it's remarkable. But we have no idea how much was torn down and redone along the way. Modern construction has zero tolerance for that. Every rework is a visible cost, a delay, a contractual issue. The drawing exists precisely to eliminate rework before it happens, to resolve problem on paper where fixing them cost nothing, rather than on site where fixing them cost everything. When you compress time, everything else changes too. You can no longer afford for knowledge to transfer slowly through demonstration. You can no longer afford for a master craftsman to carry the vision in his head and pass it on gradually. You need every person on the site, the contractor, the subcontractor, the steel fabricator, the facade installer, to know exactly what they are building before they show up. Because rework is catastrophic. A structural element built in the wrong location, a facade panel fabricated to the wrong dimension, a duct that clashes with the beam. These aren't just inconveniences, they are expensive, time consuming, sometimes irreversible problems. And the only way to prevent them is to communicate the design with absolute precision in advance to everyone who needs to know. That's what a drawing does. Let me be very direct about this. A construction drawing is a medium of communication. That's its primary function. Everything else, the standards, the conventions, the title blocks, the revision clouds, all of that exist in service of that one purpose. You are communicating what is in your head to someone who is going to build it with their hands, across distance, across time, across professional disciplines, across languages sometimes. And that communication has to be unambiguous, because ambiguity on a drawing becomes a problem on site, and a problem on site becomes a cost, and a cost becomes a dispute, and a dispute becomes a delay. This is why we draw. Now, once you understand that core function, everything else falls into place. Any project of real scale has dozens of decisions happening simultaneously across site. You, as the designer, are not there for most of them. The drawing stands in for you. It answers every question before they get asked. A good drawing set means the contractor isn't calling you every hour because the information is already there. Before construction begins, someone has to figure out what it's going to cost. To do that, they need to know how much material, what specification, what quantities, and what finishes. All of that comes from drawings. Without drawings, you're guessing. In construction, guessing is expensive. This one is underrated. The process of drawing something in detail forces you to confront reality. How does this joint work? Where does the water drain? How does this panel attach to the structure behind it? I've seen beautiful concept designs fall apart the moment someone tries to draw them in detail, because the detail reveals that the idea simply didn't work. The drawing is also a reality check on your own design. We don't build as architects. As architects and designers, we design, someone else builds. And for that someone to agree to build it, they need to price it. And to price it, they need to know what they are pricing. A contractor cannot submit a bid without a drawing set. The drawing makes the entire commercial transaction possible. Modern buildings are not just simple objects. Structure, MEP, facade, interiors, landscape, multiple disciplines, often working in different offices, sometimes in different countries, all contributing to one building simultaneously. These disciplines need to talk to each other constantly, not in meetings, in drawings and models. A clash between a structural beam and a mechanical duct caught in a drawing cost nothing to fix. The same clash caught on site can cost weeks and money. Let's talk about how we actually produce drawings, because this has changed dramatically over the last 50 years. It started with hand drafting, pencil on paper, then ink on vellum, paddle bars, set squares, technical pens. Every line drawn by hand. A major revision could take days of careful erasing and redrawing. The drawings were physical objects, rolled, stored, physically transported to site. Then came CAD. AutoCAD changed everything. Lines were still lines, still 2D, but you could copy, mirror, offset, edit at a speed that hand drafting couldn't touch. Drawings became files you could revise and reprint. Collaboration became easier. The industry moved fast. Then came BIM, Building Information Modeling. And this was a genuine shift in thinking. Not just in tools. Instead of drawing lines on a screen, you're constructing a virtual building. A model with real data attached. Wall types, material specifications, structural loads, door schedules, quantities. And from that model, you extract drawings. The floor plan isn't drafted anymore. It's derived from the model. Change the model, the drawing updates. This is where we are now, and it's a smart process, But here's what hasn't changed. Drawing still needs to come out the other end. Contractors still need them. Approval authorities still need them. The output is the same. The intelligence behind generating it has just improved significantly. So, can we get rid of drawings eventually? Well, partially yes. We are already seeing model to fabrication workflows where the drawing is bypassed entirely. CNC machines, robotic assemblies, certain kinds of 3D printing. These take geometry directly from a digital model and fabricate without a human ever reading a sheet. For specific building components, this is already happening. But for full buildings, for regulatory approvals, for multi-party coordinations, for legal documentation, for site teams that need something they can mark up and hold in their hands, drawings are not going anywhere soon. And here's something worth saying clearly. We don't just need people who can produce drawings. We need people who can read them, execute them. That skill is eroding as the industry gets more digitized, and it shouldn't be. If you work anywhere in construction as a contractor, site engineer, project manager, quantity surveyor, reading technical drawing is the bare minimum. It is not optional. So back to where we started, the Taj Mahal, no CAD, no Revit, no drawing set, and it's still standing 400 years later. They had something we don't, unlimited time, a craft tradition that carried knowledge across generations without writing it down, and an acceptance that error and rework were simply part of the process. Nobody was counting the cost of fixing something twice. Nobody was tracking delays against a contract. We don't have that luxury. We have deadlines, we have multiple disciplines, we have contractors who need to price before they build. And we have absolutely no appetite for that kind of open-ended risk. That's why we need drawings. Well, on that note, this is the end of the video. I hope I was able to add some perspective. I will see you in the next one.